right. So we are going to finish 1.4. And the reason why I sort of separated this section from yesterday's section is yesterday's ideas, adding, subtracting, multiplying, dividing, rational expressions, those are sort of things you do in everyday math classes. The things we're going to do today, simplifying compound fractions, rationalizing binomials, you do them in everyday math as well, but they're more, you'll do them a lot in calculus. So I sort of want to do its own separate thing. Genesis, did you have a question?
No.
Okay. So we are going to talk about compound fractions. It will get the main title, but we'll also squeeze in rationalizing in there as well. So just in case you don't know what a compound fraction is, a compound fraction is a fraction, where the denominator and or numerator are fractions themselves. So it's basically a fraction within a fraction. In math, the word compound usually means more than one. It usually means put inside of each other. So it's like fraction inception. You look at a fraction, boom, there's another fraction, there's another fraction. Question?
So wouldn't that just be dividing fractions?
It would not necessarily be dividing fractions because you might have like pluses and minus terms within the numerator as well. We'll take a look at an example here. And as a matter of fact, yes, we will eventually simplify it down to dividing fractions. There are lots of different techniques to handle these situations. I'm only going to focus on two primary ones. Method number one. This is a method that's in all my years of teaching this. This is the method that kids tend to gravitate towards, which of course means this is the method that I personally do not use, but hey, kids like it. It is to treat the numerator and denominator, is that an I? Yeah, denominator, as two separate expressions. So for example, let's look at this compound fraction. Simplify x over y plus 1 all over 1 minus y over x. So it's sort of like dividing by a fraction, but I don't have a simple fraction because we got those plus 1s there and those minuses there. I hope everyone can see, and I learned how to bold today, so very neat. I hope everyone can see that this right here is the main fraction bar. So within the numerator of the main fraction, I have fractions nonetheless. So if you want to simplify this guy using this technique, I'm going to get some scratch space here. You sort of have to treat the entire numerator, this guy here, as one separate problem, and the whole denominator as one separate problem. And you just do them, well, separately. So let's just look at the numerator here, the yellow part. We have x over y plus 1. Well, gee, isn't that just adding a fraction? That's stuff we did yesterday. So to do this, we basically recall yesterday's skill sets. To add and subtract fractions, they need to have the common denominator, yada, yada, yada. Everyone knows what to do from this? Yeah. The 1 needs to be a y over y. And then you combine it as one fraction. And then you just go ahead and work the denominator separately. So this will be the denominator work. Same thing. Oh, gee, it's subtracting fractions. So common denominator, all that spiel. So the 1 becomes an x over x. Pretty easy example. Sort of picked a trivial one. And then now that they have the same denominator, we can squish them together as one fraction. So all of this scratch work basically says I can change the denominator into this guy and I can change the numerator into this guy. So instead of having pluses and minuses everywhere, we've transformed this problem into one fraction, x plus y over y, divided by another fraction, x minus y over x, which I hope we know how to do. Hey, it's a dividing by a fraction problem. We did this yesterday. When you divide by a fraction, multiply by the reciprocal of the divisor. So yeah, I guess in some sense, Katie, you're right. All of this is just dividing by a fraction, but you have to do a little bit of legwork before you can transform it into a dividing by a fraction problem. And then you just go ahead and multiply straight across. As I said yesterday, I'm one of those teachers where if you want to leave it in factored form, that's A-okay by me, so you don't actually have to multiply if you don't want to. You do that on the test, I'll give you full points. Or if you just want to distribute, that's A-okay as well. So either one I will accept. Right. Not too bad. So don't let the fact that you have fractions upon fractions scare you. It's just two problems in one. Simplify the big numerator, simplify the big denominator, put them together, multiply by the reciprocal. Questions? As I said, this is the method that historically students like to do. More power to you. As long as it makes sense to you and you're accurate, I'm happy. It's actually not the method I prefer. So let's do the same example. And I want to show you my method just in case the few of you, it's very rare, actually like doing it. So the method I like, well, it sort of addresses the problem. Compound fractions, they look scary because of all of those fractions. So why not just get rid of it? This method is the clearing the fraction method, also known as clearing the denominator. And the only skill sets from yesterday that we need is to be able to find LCDs. If you can find LCDs, you can clear the fraction. So let's do the same example, so we should get the same answer. So what was it? X over y plus 1 all over 1 plus y over x. Now, this is sort of tricky. Hey, Mr. Vogt just told us to find the LCD, but I have fractions everywhere. Which LCD do we find? When you want to do this technique, you have to look at the inner fractions. And what do I mean by that is, again, if this is the main fraction bar, the inner denominators is this y here and this x. So you want to find the LCDs of the smaller fractions that are within the bigger fraction. This is a pretty simple example. Just by looking at it, we don't have to do any fancy writing. Ooh, forgot to unbold. Someone shout out, what's the LCD here? It's just x, y. Perfect. Right? Just put them together, x, y. Once you have the LCD, the technique is just multiply everything. Literally every single term gets multiplied by the LCD. So this gets multiplied by xy, this gets multiplied by xy, this gets multiplied by xy, this gets multiplied by xy. And the reason why we do that is because we're using an LCD, the least common multiple of the denominators, every single factor of the denominator should be there, meaning all the denominators should cancel out. Hopefully we can see that in the top left term, the y's are gone, and in the bottom right term, the x's are gone. So once you have canceled all the denominators, just multiply what's left over. So this equals what's left over here is x times x, which is x squared, plus what's left over here is 1 times xy, which is just xy, all over what's left over here is just xy times 1, which is just xy again. Oh, sorry, didn't copy it correctly. There should be a minus here. Minus. Minus. And then what's left over here is y times y, which is y squared. Right. Yeah, I didn't copy down the problem correctly. I originally made this a plus when it should be a minus. And as you guys can see, it's identical. It's the same answer that we got from method number 1. So whatever method you guys want to use, you can see this answer is the same as this answer. Whatever method you want to use is perfectly fine by me. Okay. I like method 2, but I'm not going to be upset if you don't like it. Questions? Comments? I'll take that as a no. So that's sort of one thing that you'll do a lot in calculus, simplifying compound fractions. Another thing you'll do a lot in pre-calculus is rationalizing. Now, you're probably thinking, hey, we already did rationalizing. Why are we doing it again? Well, in the previous lessons, we rationalized monomials. You'll see a lot of binomials in calculus. So this is the idea. To rationalize binomials that contain square roots. And what do they look like? So I'm just going to jot down a few random examples. Like 2 minus radical 3 is an example of a binomial that has a radical. There's 2 pieces and there's a square root. The square root could come first. You could have like square root of x plus 4. That's a binomial with the square root in it. Or both of them could be square roots. Square root of 5 plus square root of 7. That's a binomial with square roots in it. So all of those instances are examples of binomials that contain square roots. And if I want to rationalize that, you must multiply by the, I'm going to be fancy and bold this, conjugate radical. Isn't that fancy? Easy peasy. Of course, a definition or a big idea is completely useless if you have absolutely no idea what that is. So let's just quickly define what a conjugate radical is. So vocab. A conjugate of a binomial. So conjugates only apply to binomials. Although if you had like even number of terms, you can create conjugates by grouping. A conjugate of a binomial is the same binomial. That's sort of weird. Something's different, but it uses the same binomial. With a little tweak. A conjugate of a binomial is the same binomial except with the opposite middle sign. Emphasis on middle. Right. So if I have a binomial floating in space, the conjugate of that guy would be the same binomial, but the middle symbol is different. For example, 2 minus radical 5 and 2 plus radical 5. They're considered conjugates of each other. Identical binomials, except one's minus, one's plus. The emphasis on the middle sign is important. A lot of kids, if you're going to mess up here, you're going to flip both symbols, and you're not supposed to do that. So if I asked you, hey, what is the conjugate of negative 3 minus radical 7? You keep the first as negative. You only change the middle sign. So the conjugate of this guy would be negative 3 plus rad 7. That's it. Can you guys think finding conjugates are easy?
Hi, sorry. Do you have a potty bucket?
Unless they took it from last year.
This last container thing?
Did they remove it from the classrooms last year?
I don't know.
You're messing up my
recording. Want to explain what a potty bucket is?
I have it.
Yeah.
So whoever is going to listen to this recording will know that we talk about potty buckets. Okay. So if you guys can find conjugates, which I think very easy to do, congratulations, you know how to rationalize, because all it is multiplying. So let's take a look at an example. Suppose I ask you to rationalize the denominator and we had 1 over 1 plus rad 2. Clearly, the denominator is a binomial that has a radical. So to rationalize him, I'm going to multiply by the conjugate. The conjugate is just the same piece, same binomial, 1 and radical 2, except he's going to be a minus. And of course, what we do to the bottom must do to the top. Now, my rule of thumb is that when I do conjugates, I typically do not distribute out the other side. What do I mean? We are rationalizing the denominator here, so normally I would leave the numerator in factored form. But since this is a pretty easy problem and the numerator started with the 1, distribute the 1, it stays the same, I'll go ahead and multiply it out. So in the numerator is 1 minus rad 2. Now in the denominator, you could FOIL, but you should not have to. We choose conjugates for a reason. So recall, when you multiply two conjugates, right, same binomial, but one's minus, one's plus, you shouldn't have to draw all those arrows and tunnels. It's simply the first guy squared minus the second guy squared. The product of two conjugates is the difference of the squares. So in the denominator here, I don't have to do a lot of thinking. It's going to be this guy here squared, so that's going to be a 1, minus, it's going to be this guy squared. And if you square a square root of 2, it's just a regular 2. And then you go ahead and do math. 1 minus rad 2 over 1 minus 2 is a negative 1. And of course, when you divide by negative 1, you just flip the signs. Oh, well, please disregard the fact that I forgot to change back to black. That's rationalizing. I could ask you to rationalize the denominator. I could also ask you to rationalize the numerator. It really doesn't change the concept. So let's do one really quickly here. But I do want to do this particular example to showcase one concept. Question? All right. So if I ask you to rationalize this numerator here, radical 4 plus h minus 2 over h. The reason why I want to do this example is, kids get confused. Oh my God, there's pluses and minuses. I got multiple things. Well, I hope people can see that in this problem, this right here is one piece. It's glued together by that radical. So the binomial, this is the main symbol. So when I rationalize, it's this guy that I change. I would not change this guy. Don't change the inside plus symbol because that is not the binomial part. It's the subtraction here. So when I multiply, I would be multiplying by rad 4 plus h. That stays put, but instead it's going to be a plus 2. Right. So that's the only reason why I wanted to do this example. So just to forewarn you that you're only going to flip the main middle symbol. And then, of course, you just multiply it all out. Again, the numerator, I should not have to do all these arrows because it's just the product, the difference of the perfect squares. So when I square the first guy, the radical goes away. So it's just 4 plus h minus, when I square the second guy, 2 squared is 4 all over. And again, typically when I do these problems, I do not multiply out the other side. I just leave it factored form. So in the denominator, I'm not going to distribute. Instead, I'm going to leave it in factored form. Because 9 out of 10 times when you do these rationalizing problems, stuff will cancel out. So in the numerator, the 4's cancel, plus 4 minus 4. So you're left with h over h, rad 4 plus h plus 2. And you guys can see how the h is reduced now? Yeah. So when you guys are doing these rationalizing problems, that will usually happen. Something should reduce out. There you go. We rationalize the numerator. So rationalizing binomials, not very tricky. Just multiply by the conjugate. So simplifying compound fractions, rationalizing binomials, those are good skills to have for calculus. That is 1 4b.
Yeah. So I thought you can't have variables in the denominator.
So like it's not a law.